Hi, math lovers. Welcome to notes number 132. We're working in chapter 9 right now. Really exciting chapter. We're going to work on linear and nonlinear systems. So right away, you're thinking linear up. Linear means it's a line. Nonlinear means it's not a line, okay? So remember from Algebra 1 back in the day, you had a couple different methods for solving systems. You could solve substitution. You could graphically solve them in elimination. You probably got away from a lot of the graphical solving, but we'll bring that back today. I'm going to pull 3 examples from your textbook. So first one is number 13. You take a look at the problem, and the first thing you're thinking is that I've got x minus y equals -4. That is a line. And I can't help, and you're probably the same as me. Maybe you want to move it around. Maybe you want to think about this as x equals, bring the y over and make it y minus 4. I mean, maybe that's where you want to go. Maybe you're thinking to yourself, move the y over and make it x plus 4. So many different ways you could think about it. All right, and the second way has an x squared minus y equals -2. That's going to give me a parabola. But the directions in our textbook actually say to solve using substitution. So I'm going to follow Ron's directions, and I'm going to take this value of y minus 4, and I'm going to plug it into the other equation, and I'm going to go ahead and solve. So everywhere there's an x in the other equation, I'm going to put in a y minus 4. So I have y minus 4 squared minus y equals -2. Oh, we're ready to FOIL. We just love foiling. Y squared minus 8y plus 16 minus y equals -2. Let's bring everything over to one side. So I have y squared minus 9y. Bring this 2 over, so it's plus 18 equals 0. Oh, trinomial factoring. Oh, we're not losing any time here. So it's y minus 6 times the quantity, y minus 3. Straight up, I know that y is going to equal 6, or y is going to be equal to 3. I'm going to take those values for y and plug that back in to my original, or you can plug it in here to this one where you've solved for x. So I almost say here that x is equal to 6 minus 4, so therefore x is equal to 2, or x is equal to 3 minus 4, so x is equal to -1. So I have 2 ordered pairs, 2, 6, and -1, 3 as my solution. Now, do you think it's weird that I have 2 solutions? Not at all, because think about what this graph would look like. So if I were to go ahead, let me change this original form to y slope-intercept form, which would be y is equal to x plus 4. And this second one, I'm going to change to y is equal to x squared plus 2. We know that this first one is going to be our line, and the second one is going to be our parabola. All right? And a quick little sketch of that. 1, 2, 3, 4. Here I am with my y-intercept. Up 1 over 1, up 1 over 1. So I'm going to have a line that looks just like this. And my second one's going to be a parabola, which with a y-intercept of 0, 2. And on my parabola, that looks like this. And if you look at that, it makes sense that this is going to intersect in 2 locations. And where does it intersect? It intersects over here at 2, 6. And it intersects over here at -1, 3. So my answers make sense to me. It makes sense to me, so I'm really happy with that. All right, so beautiful problem, just a beautiful problem. Now, suppose you didn't like to follow directions, and suppose you preferred to take this entire problem. Ron said substitution, but what if you said, hey, you know, I love elimination. I just stare at this problem and I see x minus y equals -4 and x squared minus y equals -2. And if I could just go ahead and change all the signs, like maybe put make this negative, make this positive, make this positive, right? And I were going to go ahead and add these 2 equations together. Pachoo! That falls right out, and I'm left with x squared minus x equals 2. All right, so I'm thinking right away, I'm thinking trinomial factor, you know it, trinomial factoring. So I have x squared minus x, bring the 2 over, so minus 2 equals 0. So I've got x minus 2 times the quantity, x plus 1 equals 0. So I know x is equal to 2, x is equal to negative 1. This is the story we found before. You could take those values, plug them back into your original, and we get the same ordered pairs that we came up with before. So that's totally your call. It's your call whether you want to use elimination, or you want to use substitution, or you want to do graphically. So we took this one problem right here, and I did it all 3 ways. I did it with substitution, I did it with graphing, and I did it with elimination. All right, we got the same answer all 3 times. That's the key. You want to go ahead and get the same answer, right? There's no way. If you got different answers, friends, you know you got something wrong. Okay, one quick more problem. This one's from your textbook again. It is a word problem. I just love those word problems. And even better than a word problem are those geometry questions. So this is number 83 from your textbook. It says, what are the dimensions of a rectangular tract of land if its perimeter is 44 kilometers and its area is 120 square kilometers? Okay, so they're asking me a geometry question, and I'm talking about a rectangular tract of land. So you know what I should do? I should draw my picture. I have my width and I have my length. I know my perimeter is equal to 44. And my formula for perimeter, of course, is 2 times the length plus 2 times the width. And I know my area is equal to 120. And I know my formula for area is length times the width. Now, I know you guys, you see 120, you're my math rock stars. You're thinking to yourself, I bet it's 12 and 10, and then you plug it back in and you make sure it works. Great, but that's not gonna work for you every single time. You're gonna need something to fall back on. Everything through here by 2. I'm going to have 22 is equal to length plus width. Second equation here, maybe I'm going to use substitution. Plug it right in for that. Is equal to 22 minus W times W. Doing some really fun FOIL. I've got minus W squared. I'm going to bring, this is my diva positive. So bring her over W squared minus 22W plus 120 is equal to 0. Some super right, you saw it. W is equal to 12. And what you're going to end up doing is figuring your length from that one is going to be the opposite. So does it matter which one I call the length? Not at all. All right, make sure you always label your work, okay? This would be as if, and I asked you to solve it 3 ways. Oh, wouldn't that be fun? You had to use substitution, graph, and elimination, just like I did here. Have some fun with your problem set. Bye, kids.